Hi, and welcome back to this AI-900 Azure AI Fundamentals course. In the previous lessons, we explored machine learning concepts, Azure machine learning, computer vision, and text-based workloads with Azure AI language. In this lesson, we will focus on speech and translation using Azure AI Speech. By the end of this lesson, you should be able to explain what Azure AI Speech is used for, distinguish between speech-to-text, text-to-speech, and speech translation, understand where speaker-related features might fit conceptually, and map common exam scenarios to the correct Azure AI Speech capability. If this lesson helps you with your AI-900 preparation, remember to like the video and subscribe to the channel so you don't miss the upcoming lessons. Let's start with the overall idea. Azure AI Speech provides services to work with spoken language, while Azure AI Language focuses on text, and Azure AI Vision focuses on images and video. Azure AI Speech focuses on audio and voice, whenever the input is sound captured from a microphone or an audio file, and the goal is to recognize, generate, or translate spoken words. Azure AI Speech is usually the correct service to think about. In exam scenarios, if you see phrases like transcribe phone calls, make the app talk back to the user, or translate spoken language in real time, those are clear hints that the question is about Azure AI Speech. Now let's look at speech-to-text, also known as speech recognition. Speech-to-text takes an audio stream or file containing spoken language and converts it into written text. Typical examples include transcribing customer service calls into text, converting meeting recordings into transcripts, allowing users to dictate instead of typing. This is useful for search, analytics, compliance, or simply for convenience. On the AI-900 exam, if a scenario says, convert audio recordings into text, produce transcripts of meetings, or allow users to speak instead of typing, the correct capability is speech-to-text with Azure AI Speech. The important thing to remember is input, audio with spoken language. Output, text that represents what was said. Now let's reverse the direction and talk about text-to-speech. Text-to-speech takes written text and generates synthesized voice. It allows applications to speak to the user. Examples include a virtual assistant that reads responses aloud, a navigation app that speaks directions, an app that reads content to users who prefer audio over text. The AI-900 exam may describe scenarios like an application should read messages back to the user using natural voice. A system needs to generate spoken responses from text. These are all cases for text-to-speech. Here, the transformation is input, text. Output, audio with spoken language. Another key feature for the exam is speech translation. Speech translation combines speech recognition with machine translation. It allows you to take audio spoken in one language and produce text or audio in another language. For example, convert spoken English into spoken Spanish. Convert spoken French into written English text. Support real-time voice conversations between people who speak different languages. Typical exam hints include translate spoken language from one language to another in real time. Allow two users speaking different languages to communicate by voice. Provide subtitles in another language for live audio. All of these scenarios point directly to speech translation. In summary, speech-to-text audio in, text out. Text-to-speech text in, audio out. Speech translation audio in one language, text or audio out in another language. Now let's briefly talk about speaker-related concepts. Some speech solutions also consider who is speaking, not just what is being said. Although AI-900 does not expect deep details, you should be aware of the idea. Examples of speaker-related features might include identifying which participant is speaking in a multi-speaker conversation, verifying a speaker's identity with voice as a factor in authentication. When the scenario focuses on who is speaking, like distinguishing between multiple speakers in a call, it suggests a feature related to speaker recognition or diarization. on top of basic speech-to-text. Again, at AI 900 level, it's enough to understand that some speech workloads focus on content, while others also focus on the speaker's identity or role. Azure AI Speech is often used together with other Azure services. For example, a call center solution might use speech-to-text to transcribe calls, then send the transcripts to Azure AI Language for sentiment analysis and key phrase extraction. A virtual agent might use Azure AI Speech to listen to the user and speak responses, while using other AI services to understand intent and generate the best answer. A translation app might combine speech translation with a text-based translation service and a chat interface. In AI 900 scenarios, it's important to see where Azure AI Speech fits in the bigger picture. If the challenge is turning audio into text or text into audio, or translating speech across languages, then Azure AI Speech is the core service involved, often working alongside other Azure AI services. Let's walk through a few example scenarios to solidify the mapping. Scenario 1. A company wants to generate transcripts for all customer support calls so they can analyze them later. Here, the goal is to convert recorded audio into written text. The correct capability is speech-to-text. Scenario 2. An accessibility feature should read chats and notifications aloud to users. In this case, the input is text and the output is spoken audio. This is text-to-speech. Scenario 3. A travel app should allow a tourist to speak in their native language and have the app respond in the local language of the country they are visiting. This is a classic speech translation scenario. Scenario 4. A system needs to support voice-based conversations between users speaking different languages, with minimal delay. Again, this points to speech translation, possibly combined with text-to-speech for both sides. Scenario 5. A contact center wants to identify which agent and which customer are speaking at different times in a call recording. Here, the emphasis is on distinguishing speakers. This suggests using speech-to-text plus speaker-related analysis, such as speaker diarization. In all these examples, the common pattern is that the data is audio, and the tasks all align with capabilities of Azure AI Speech. Let's recap the main points from this lesson. Azure AI Speech focuses on spoken language and provides speech-to-text to convert audio into written text, text-to-speech to generate spoken audio from text, speech translation to convert speech from one language into another, and additional speaker-related concepts in some solutions, such as identifying who is speaking. You also saw how speech services can be combined with other Azure AI services, such as Azure AI Language for deeper analysis of transcripts, or Azure Bot Service for voice-enabled virtual agents. For the AI 900 exam, remember to check whether the input is audio or text. Identify whether you need recognition, speech-to-text, synthesis, text-to-speech, or translation. And look for clues about real-time translation or speaker identity. If this lesson was helpful, please like the video, subscribe to the channel, and continue to Lesson 9, where we will explore another key area of the Azure AI platform to complete your AI 900 preparation. Thank you for watching.